Hi guys, let's look at today's LeetCode task. Minimum index of a valid split. An element x of an integer array R of length m is dominant if more than half the elements of array have a value of x. 1 minute. It's dominant if element x of an integer array R of length m is dominant if more than half the elements of array have a value of x. You are given a zero-indexed integer array nums of length m and with one dominant element. You can split nums at index I into two arrays. Okay, I would be last element of first array. But the split is only valid if I less or equal to 0 and less than n minus 1. Okay, numbers I and numbers have the same dominant element. Here numbers I, j denotes the subarray of nums starting at index I and the ending at j, both ends being inclusive. Okay, particularly if j less than I, then nums I, j denotes an empty subarray. Return the minimum index of a valid split. If no valid split exists, return -1. 0, 1, 2. If we split by this index, an array element is dominant since it occurs twice in the array and and 2 bigger than 3. Yes, an array is dominant. Here output 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Split the array. If element 1 is dominant since it occurs thrice in the array. Okay, input -1 because we cannot find the split with dominant element. Length I has exactly one dominant element. Numbers has exactly one dominant element. So we can easily find dominant element because that should be an element that would be presented in the array most of the times. It is most frequent element in the array. Occurs in the array more often than other
Occurs in the array more often.
Occurs in the array more often than other elements. After that, we can run through the array and find index of split. What do we need for that? We need a map that would contain an element, a count of elements. This is how we will find dominant. Number's length would always be bigger or equal to 0, which means that we can say that dominant would be numbers at index of 0. Okay, yes, dominant element. Yes, dominant element. Then we can go through numbers. For const number of numbers, and what we should do, if map has number, then we will increment it. Map set number map get number plus 1, else map set number wap 1 if map doesn't have number yet, and result would be map get number. I would simplify it later. Const count, and if count bigger than map get dominant, then dominant would be number. So dominant, yep. Yep. Count get number. Count would be if map has number, then map get number plus 1 or 1. Map set number count if count bigger than dominant, then dominant will be a number. 1 second, please. Okay, let's continue. So we have a dominant number. What we need to do is to check if the index of that we can split, in which we can split, and in which we will have dominant. So index can be from index is inclusive, so can be array empty n-1, index less than n-1, but it can be equal to 0. Let I equal to 0, I less than n-1, I plus plus. So what do we need now? We need to split an array and say that it is dominant. We already have a map. I would create next map with the same structure that would contain left values. Map, or I can just say let dominant count would be 0. We don't need any other elements. And here what we will do, a dominant count, let's say left dominant count would be equal to 0, and right dominant count would be equal to, or we can add just constant count would be equal to map get dominant. Yep. So if I equals to dominant, then left dominant count would be incremented. Right dominant count would be dominant count minus left dominant count. So as I understand, we need to have the same dominant element, so at least one dominant element should be presented here. If left dominant count bigger than 0 and right dominant count bigger than 0, result would be -1. And I is the number of left elements. If left dominant count multiplied by 2 bigger than I, const left dominance, let's say left dominant count more than half, bigger than I, and right dominance would be right dominant count multiplied by 2 bigger than arm's length minus I. For example, here 0, 1, 2, yes, 2I is 0, 1, 2, 2 multiplied by 2 bigger than 3, 1 multiplied by 2 bigger than 1. If we will have 1 multiplied by 2 is not bigger than 3. Yes, if here we have left dominance and right dominance, then we can return I. And we don't need a result L because we need to return minimum index. In other case, we're returning -1. Well, let's check what we have. We have a map, we have a dominant number, which is initially the first number of numbers array. Dominant, we're iterating through numbers and counting amount of numbers. Map has number, we're incrementing it. Yep, in other case we're taking 1, then we're setting it to the map, and if count is bigger than then map get dominant, then dominant would be num. The first one would be false because we've just set it. Okay. Got it. So dominant count is the count of dominant values. Left dominant count would be 0, and we're iterating through them. If I less than n, if number would be numbers at index I, if number is equal to dominant, then left dominant count, we're incrementing it. Right dominant count would be dominant count minus left dominant count, which is fair enough. And if we don't have dominance in left, or we don't have dominance in right, we can just continue our loop. If we have dominance in left and in right, then we're calculating if our dominant number is dominant in left and our dominant number is dominant in right. Minus I, number's length. Okay, if we have both dominants, then we can return I. Let's try map, of course. Forgot operator new n would be nums length. Okay. Yep. Output 1, output 2. So output 1, this element left dominant count should be 1, right dominant count should be 2. 1 multiplied by 2 bigger than 1, bigger than 1, 2, 0, 1. Bigger than I plus 1. This is index, and here I is 1, length is 4, I plus 1. Subarray. Sorry. Yep. Wow. Great. How can we simplify this solution? We can say that right dominant count const left subarray length would be this, and we can multiply it by this left subarray length. Here everything is okay, here it is okay. Numbers, well, I think it's pretty optimal algorithm. We can remove this because in other case map get dominant will return undefined. It would be false. No, it would be better to keep it, or we can just say -1, or we can just say something, I don't know, doesn't matter. Let's return as it was. Okay. Let's submit. And what about complexity? Time complexity would be O, big O of n, because we just have 2 loops through numbers, and space complexity would be O of n as well, because in map we will store all unique values, and if all numbers are unique, then we will store all of them. Let's look at other solutions. Maybe there will be something better. Find dominant element. Array. Candidate. Dominant. Find dominant. Count plus filter. Oh, I don't like this approach. Filter, it's not optimal at all. Yep, just the same. And beats 100%. Oh my god. Candidates, count candidates. Boyer-Moore majority voting algorithm. Count is 0. Candidate would be equal to number. Okay. Count. Count the occurrences of the dominant element. Numbers reduce from 0. They're not sorted. Would it work? Because last element can be like some number that would be not equal, and then majority voting. Okay, I will need to read about it a little bit later. Okay guys, thank you very much. It was a nice task.